Hi there, I'm Evan Flatt, Director of Solutions at GRYFN. And today, I'm excited to give you a walkthrough of our revolutionary software, the GRYFN Processing Tool. Designed to optimize your data management and pre-processing tasks, the GRYFN Processing Tool is your go-to solution for streamlining your workflow, enhancing efficiency, and unlocking valuable insights. In this demonstration, we'll explore the tool's intuitive interface, powerful features, and seamless integration capabilities. By the end of this demo, you'll understand how the GRYFN Processing Tool can transform your remote sensing operations and empower your business to achieve new heights. So without further ado, let's dive into the GRYFN Processing Tool. The GRYFN Processing Tool is a powerful software solution specifically designed to process raw sensor data from hyperspectral line scan, LiDAR, and high-resolution frame cameras, converting it into orthorectified products such as geotiffs, Envi rasters, and last point clouds. To ensure efficient data management and maintain a well-organized workflow, the GRYFN Processing Tool starts by bundling raw data into GRAW folders. This bundling process consolidates all raw data files and their associated metadata into a single, easily manageable folder. By storing relevant metadata alongside the raw data, the GRAW folders enable users to keep track of essential information such as acquisition team, sensor type, and weather details, streamlining the data processing pipeline. Let's step through the bundling process. When we open GRYFN Processing Tool, we're greeted at the welcome screen here. To begin bundling data, we can select the Bundle Data tab on the left side of the screen. Here, we have two options, creating a new bundle or adding data to an existing bundle. Let's create a new bundle. Now, we can see all the required inputs for the bundling process. A system calibration file, a processing extent, which is optional, and the path to the raw data and any other data that should be included in the bundle. Let's start by selecting the system calibration file. In this case, I also have a processing extent, so let's select that as well. Now, there are two options to select the data to include in the bundle, single source and multi-source. In single source, we can select a single directory. The software will parse that directory and look for all data files that may be relevant to the calibration file. In the multi-source method, we're able to individually select directories for each data type. The logs directory here will allow you to bundle any data in any format in a particular folder. Next, we can add some more metadata to include in the bundle. We can include things like the pilot that flew the mission, a location, or any notes about the weather conditions or other anomalies. Lastly, we can give the bundle a name. I'll just call it Demo Data. Now we can create the bundle. As the bundling process continues, we can see a progress bar on the left side in the job queue, as well as an elapsed time for the bundling job. On the right side here in the File Explorer, we can also see that the GRAW folder is being written into the directory I specified. We can see here the bundling job completed successfully and we've received a system notification. Bundling this data took only 3 minutes. After the bundling process is complete, we have the Open Data Bundle option here. This opens up the data bundle in a new File Explorer so you can see your raw data. Let's take a look at what's in the GRAW bundle. First, in the root directory of the bundle, we can see a few text files. The YAML file is the pipeline instructions that the runner received to bundle the data. Here we have the raw data paths to each of the sensor types, we have the path to the calibration file, and the metadata we included on the front end. The log file is the console output from the bundling process, just to have as a record. The extent file is a copy of the extent file we selected on the input side. This can be used later in the processing to trim the data products. The calibration file is also included here. This denotes what the sensor IDs are and all of their calibration parameters. We can see that the sensor IDs in this file correspond with the folder names in the GRAW directory. Raw sensor data from each of the sensor types is stored in these folders. Lastly, the mission data YAML includes path to the bundled data, a checksum value, and again, a copy of the metadata. Now that we've bundled the data, let's take a look at processing. We can go to the New Job section of the software here. Now we're greeted with the option to select a pipeline. You can see a drop-down list of different pipelines that I've saved in the software previously. Let's use the demo pipeline I've created earlier. We have a few different options at the top here. We can edit the pipeline, export the pipeline to a file to share with others, or delete the pipeline from the software entirely. I'll edit the pipeline so we can see what's inside. You can see the pipeline is broken into individual tasks for each sensor type. In this particular pipeline, I've defined tasks to process GNSS data, LiDAR data, hyperspectral VNR data, and RGB data. With the GNSS data type, we can see that we can select GNSS processing modes as well as other options. In LiDAR, we can select the minimum and maximum range values and a field of view to process the LiDAR points from, and the product configuration, such as a combined point cloud, where we can select outlier removal, or creating a surface model with settings such as resolution, median filter, and a height percentile. We also have the option of selecting the extent file. If we select to use the processing extent, this uses the extent file that was available in the GRAW folder, but you can select from a separate file or use no extent, which will process the maximum extent of the data. We have a similar configuration for VNR, where we can select the processing configuration as well as the product configuration. This is where you can change spectral binning, scale factor, data type, resolution, and generic file names. We also have the option to output a 3-band mosaic rather than the full hyperspectral mosaic. RGB has the same configuration with an initial processing configuration and a set of instructions for producing products with a set resolution based on a surface model where we can do exposure matching, color balancing, and trimming of the product extent. We can also colorize the LiDAR point cloud from the RGB data. Let's go back. Now that I've selected the demo pipeline, we can select the GRAW bundle we'd like to process data with. So selecting the demo data GRAW I created earlier, we can see the pipeline summary is giving us a small warning here. This is to let us know we should select the postback data to process, since I don't have any process data included in this GRAW bundle. So I can select the first and last T04 files from the APX folder, and that warning has gone away. We also have the opportunity to change any product or processing configuration for the other tasks, such as LiDAR, VNR, and RGB. This allows you to make small changes to your pipeline without having to build an entirely new one. Lastly, in the general settings, we can do a couple things, such as prepend GPRO names to products and append imagery resolution to product name. Because this GRAW contains hyperspectral data, we're given the opportunity to select target files and pixels to use for reflectance conversion. I can start by selecting the target files which contain the reflectance data that's visible in the imagery, then in the supporting file folder. I'll select those target files. Now I can scroll through some previews of all the data cubes and find the cube which contains imagery related to those targets, and I can select Draw Target Bounds. Using basic keyboard controls, I can zoom and scroll around the image and find a closer view of the targets. I'll start with the 11% reflectance target, select some pixels to use on that target. I also have 30% reflectance target and a 56% reflectance target. I've selected those pixels, I get an R² feedback value for the ELM. If I'm okay with that, I can save. Now we're ready to submit the dataset. Because this dataset didn't contain pre-processed GNSS data, the pipeline is going to run the GNSS processing task. We can see that happening here. After the GNSS data is processed, it will move on to LiDAR, hyperspectral, and RGB processing. Now that the GNSS data is processed, we can see that the LiDAR data is being processed. First step is to process the individual PCAP files, and then it can create the data products. Here you can see it's generating the combined point cloud, and now it's running the outlier detection. and we'll create the DSM. The DSM will be used later in the ortho rectification process for the RGB and hyperspectral data. We can see the LiDAR data processing is complete, and now we're moved on to processing hyperspectral data. We can now see that 19 minutes in, we're just about finished writing out the V-near hyperspectral orthomosaic. The last task will be to perform the RGB processing, which takes up most of the steps in the data processing pipeline. While the hyperspectral data processing is wrapping up, we can go ahead and take a look at some of the products available in the GPRO. Going into the GPRO directory, we'll see we have a products folder here. Inside that products folder, we can see all of the data products we specified in the pipeline. Starting with the LiDAR point cloud up here, this demo data LiDAR point cloud last file, as well as the DSM we created. I'm going to go ahead and open these up. I've got the point cloud open here in Cloud Compare. You can see that the colorization is wrong, so I'm going to go ahead and color each of the points by their height. We can go to the scalar field settings and export one of the coordinates as a new scalar field. We want to select the Z coordinate. Now that we've done that, we can see that the data is now colored by its Z value. We can see this agricultural field that we've collected data over. Taking a look at the left, we can see some of the information about the point cloud. This has about 50 million points in it. We can also see from a top view that it's trimmed very nicely to the extent file that we defined earlier, a nice rectangular area. Looking into the rest of the products folder, we can see for the V-near data we've produced several different files. The ones at the top here are the overall orthomosaics, but we also have these labeled flight lines. These are orthorectified flight line outputs in case you wanted to do your own mosaicing process. I'm going to open up Envi so we can look at our orthorectified orthomosaic. So here we have a nice looking orthomosaic raster. You can see that it's also trimmed by that same extent value we defined in the GRAW directory with that GeoJSON file. Now that I'm in Envi, I can also pull in the LiDAR DSM. You should see the same sort of pattern. We can see now that the hyperspectral data has been completely processed and the pipeline runner is moving on to processing the RGB data. If we look in the product directory of the GPRO folder, we can see all of those V-near hyperspectral data cubes. We have the one orthomosaic that covers the entire field. We also have the individual orthorectified flight lines. So we can open up one of these 3-band JPEG images and see that orthorectified flight line result, as well as for the complete orthomosaic. Backing up one directory in the GPRO folder, we can see that there are some other things that are in the root directory of the GPRO. We can see similar text files to what's included in the GRAW folder, including the pipeline, which includes the set of instructions that denote what was done to this process data, the log output, which is analogous to the console output you're seeing here, the calibration file, a manifest of all the data products, and then the mission data, and another YAML file that denotes the products, which is used for our Python module. In each of the sensor ID folders, we can see that there is some intermediate processing data, which includes JSON files, TIFF files, and other data that's an intermediate output of the processing. That's available for hyperspectral data, the RGB data. Okay, we've gotten a notification now that the processing job is completed successfully. So if we go into the product directory here, we should see that we do have our RGB orthomosaic as well as the colorized point cloud. And then scrolling down at the bottom of the processing log, we can see that that pipeline finished in 90 minutes. So we have our all of our LiDAR data products, which include the full point cloud and a surface model. We have all of the V-near orthomosaic, individual flight lines, as well as the full orthomosaic, and a high-resolution RGB orthomosaic as well. Once that pipeline is finished, we have this option to open the data cube product. So this opens the GPRO folder. We can go into the products directory, and again, we see all of those products. Now that the RGB is finished, we've added these. Here we have the RGB colorized LiDAR point cloud loaded into Cloud Compare. So this contains all of the LiDAR points in this LiDAR point cloud, but they've been colorized with the red, green, and blue values from the RGB orthomosaic. Here I've opened up the RGB orthomosaic in Envi. We can see that it's a 6mm resolution geotiff raster. Now that our demo data has been bundled and processed, I'm going to walk through some of the other features of GRYFN Processing Tool. So going back to the welcome screen, we can see a couple links here. The first one is a quick start guide. So this is an in-software access to a guide that sort of walks you through the basic processing workflow. We also have a link to the full software manual, which just goes into some more detail on the individual file types and processing configuration. In the settings section, we can change some of the general settings of the software. This includes the enabling the dark mode, which I have enabled here, inverting the scroll direction, setting thread utilization. So this will determine the number of threads that can be utilized for some of the parallel processing options when data is processed. We're also able to select default location settings for particular file selections. So for now, I've just changed everything to the demo directory. The last setting here is a path to the postpack batch runner executable. This is what allows you to process postpack data in the background. There's a tab on the left also for some pilot information, so we can pre-configure the software to be aware of individual pilots, so we can include their name and certificate information and renewal, so that information can be bundled into the data set and included as metadata. There's also a tab for product licensing where you can see what machines are registered under your current license. The last setting is for the Python script module. We can define a path for external scripts, a path to our pipeline executable, or excuse me, our Python executable, and additional launch arguments. Once we have the GRYFN Python module installed in that Python environment, and we determine the path to potential scripts, the software will parse those scripts and will show you the arguments that are available for each of those scripts. And these are the settings you'll be able to configure when you run a particular Python process after initial pipeline processing. So you can see that Python processing can be done either inline with a particular pipeline configuration, as we saw before. When we select the GRAW pipeline at the bottom, we can toggle the additional scripts and set their arguments. Or without, on a data set that's already been processed, we can select a GPRO data set and do the same. We can run it after the fact of running the initial pipeline. Another feature of the GRYFN Processing Tool is the job queue itself. So in this example, we just ran one job, and you can see that that job is finished here. We have the option of queuing up multiple jobs, though. So we can select multiple pipeline configurations, submit them to the pipeline runner, and they will be added to this queue and processed one at a time. This allows batch processing of multiple data sets without having to manually configure each of the pipelines in between runs. The last feature I'll mention is the versioning and updating control of the software. You can see back on the welcome screen, there's this message that says no update is available. If there is an update available, the software will download that update executable, and when the software is run the next time, that will be installed, so you'll be on the latest version of the software, and you will see this version number change. So software version control is handled automatically. And there you have it. With the GRYFN Processing Tool, you now have the power to efficiently process raw sensor data from hyperspectral line scan, LiDAR, and high-resolution frame cameras, converting it into valuable orthorectified products. While organizing data and metadata into GRAW and GPRO folders, Our software simplifies data management, ensuring that your workflow remains organized and efficient. With its user-friendly interface and seamless integration capabilities, the GRYFN Processing Tool is the ideal solution to streamline your geospatial data processing needs and elevate your projects to new heights. Thank you for joining me in this demonstration of the GRYFN Processing Tool. If you have any questions or would like to learn more, please visit our website or reach out to our team. We're always here to help. Until next time, I'm Evan Flatt, and I look forward to seeing how the GRYFN Processing Tool can revolutionize your data processing experience.